hold that thought, Pat.
Yeah, you're gonna have to explain that in more detail because I need to see the reference page to understand it. You'll wait for that. Welcome to the folks who are joining us right now. We're just setting up to go live, and today our topic is got the observer. There we go. Today our subject is planets and satellites. We're on YouTube right now, so we're all set to go. You're reminding me, sorry. I'll get the page up on our shared screen in just a minute, James. Okay, I'm working on it. There we go. This isn't even the right page. We're still on the sun here.
211.
Thank you, James. There we go. All righty. So welcome, everybody. We're going to do planets and satellites today. We are expecting it to take about 30 to 45 minutes or so, maybe not a whole hour. And I did want to mention as well quickly that we have decided to combine the last two sessions. So that would have been May 25th and June 1st. June 1st. Yeah. So we're going to take the June 1st one. We're going to cancel that one, and we're going to take all the questions that we had saved for that one and the talk about how to use the Observer's Handbook for observing programs in the RASC. And we're going to add that to the Stars and Deep Sky session. The online part, the website will reflect that shortly. And that session might be about an hour long, a little bit longer than usual. So get ready for that. And so that means that our last session will be May 25th, and the June 1st session on Zoom, I will cancel it. So if you are curious as to why you can't join, that will be why. Alrighty. On that note, today we have our trusty James Edgar here, our handbook editor. And we also have Pat Kelly, who has put together part of the planet section, specifically, I believe, the Jovian satellites. So we will get there. And I will hand it over to James for now. James.
Here I am. It's interesting that I was talking on the phone yesterday with Murray Paulson. He's given me the planet section for the 2021 handbook already. So he's well ahead of the game.
No kidding. Wow.
Yeah. This is a very intense section. He spends weeks at public libraries going through almanacs and doing web searches and all sorts of stuff to get all the information as current as he can. And we got to really give him a warm round of applause for the stuff that he does. He's really dived into it.
Good for him.
The little intro that he has there on the page 211 it says a lot in just a few sentences. He says there's nothing that replaces being there at the eyepiece, and he's right. You know, we hear lots of people at outreach events, their first time looking through a telescope and seeing Saturn's rings or Jupiter's moons, and it's astounding to see that it's live, and you got the Saturn against the black backdrop of space. And you can actually see the rings, you can see the gaps in the rings if you have a powerful enough eyepiece in your telescope. And those kind of moments are to be relished. So getting on to what he says there, we'll move on to the second page. Let's just go back to that.
Oh, sorry.
Seeing as how this is how to use the handbook. That drawing there by Michael Gatto, showing the relative sizes or the apparent sizes of the planets. So you can see that Jupiter changes in size quite a bit from its most distant or Earth's most distant turn around the sun to its closest approach. And the same for Mars. Look at Mars when it's at its furthest. It's a tiny little dot. Whereas right now it's coming up to visible. People are actually getting photographs of it because it's coming up to an opposition.
Wow.
Well, Uranus, there's not much there. Neptune, there's not much there. If you were trying to view Neptune at the naked eye, you won't succeed. It's so tiny. You have to have some kind of instrument to view it. And Venus, you look at Venus's large image is where it is almost right now. Just a thin little bit. It's actually on the right side because it's on the east side of the sun. It just passed its greatest illuminated extent, which means that it gives you the most light per area of its disk, even though it's a crescent. You know, there's far more light coming off that crescent than there is the full disk because the disk is so tiny. So, and same goes for Mercury. Mercury is a tiny dot when it's on the furthest part of its orbit, but when it's close and it's showing a phase like the moon, it can be fairly bright. There's a lot of people who have never seen Mercury, and it's not that hard to pick out. This would be a good time to see it, the next iteration, because it's coming up. It's going to be the ecliptic is almost vertical right now. If you go out at night and you can see Venus is out there, it's straight up. So the ecliptic is straight up.
Right, as opposed to in the
So
winter
you
time
should
when
be able to
it's...
pick out Mercury when it comes around. Let's just have a quick look in the month by month here, and we'll see where
Oh yeah.
Mercury is at perihelion on Sunday the 10th. That's its furthest distance from the sun.
So that's, oh, Mother's Day. A reminder for anybody who forgot that it's Mother's Day on Sunday the 10th.
So you should be able to see it right next to Venus on the 21st, 22nd nights. It'll be fairly high in the sky. No, not a long ways up, but it'd be right beside Venus. So if you can find Venus, you should be able to find Mercury. So those are some things to look for. And also Murray talks about using a good quality telescope, and he's right about that. If you have good quality binoculars or telescope, you can do a lot of planetary viewing. Like, oh, here's a little note from Bruce McCurdy in one of the chats. He says, counterintuitive point about Mercury is that in any given apparition, the closer it is to Earth, the fainter it is. The phase angle matters much more than the disk size. Yeah, exactly.
This is one of these things that I have a hard time wrapping my head around. This is
the counterintuitive part?
Yeah, this like that, you know, that the less the planet is lit up, the larger it appears to us, and therefore the brighter it appears in the sky. Is just like, I don't know, just don't expect that to happen. Yeah.
Well, it's true of Venus, but it's not so true of Mercury, because Mercury's surface and its lack of an atmosphere is much like the moon. So if you can only see a crescent, then there's not much light coming off of it. It has a dark surface, much like the moon.
Okay, interesting.
Whereas Venus, you're looking at the cloud tops. You're not looking at the surface of Venus. So the cloud tops reflect almost all the sunlight. It's such a bright object in the sky.
Interesting. Okay, I didn't realize that was why it was so bright.
Cool. All right. I'm going to pass this over to Pat Kelly, who's going to give us a little bit of information. The rest of the planet stuff is, as I said earlier, while we were offline, if you can read, then you really don't need an explanation of what's in there. Everything that you need to know is in the written portion of it. But there's some other things that we would get. And I'm going to turn it over to Pat Kelly now.
Oh, thank you very much. I guess a few things about some of the diagrams that might be worth talking about. In fact, we just scrolled to that one. Oh, the perfect timing. Just stop right there.
There we go.
With the upcoming opposition of Mars, one of the things that people often run into when you're planning looking at Mars is that Mars, and that map is actually quite good for trying to figure what the lighter and darker shades are that you're seeing on the planet at any given time. The one key thing to make note of, though, is that Mars rotates almost exactly every 24 hours, which means if you go out during opposition at 10 o'clock every night, you're going to see the same side of Mars. You're going to see very little change in it because in the time that it takes the Earth to go around once, Mars goes around once. So if you want to see different parts of Mars at opposition, the best thing to do is to stagger your observing times from the early evening to the middle of the night. And if you're one of those people who can actually get up in the early morning before the sun, that would be a good thing to do to see as much of the planet as you can. And that's one of those things that's not intuitively obvious when you first look at one of those maps. That people sort of think, well, I can see the entire thing. But if you're used to going out at the same time every night, you may get confused or puzzled or frustrated as to why you're not seeing anything else. So that's one thing about that map that's worth pointing out. The main section that I tend to do for this, and we just scroll down, is a section on the satellites of Jupiter. And this one, again, there's a diagram at the start of it. So we'll just keep, yeah, if we just back up a bit.
Back up a bit? Okay, which page?
Keep going back up. Whoa, right, yeah, right there. So there is a diagram that sort of shows what the abbreviations are for, and that's sort of an idealized view looking down on Jupiter from above. So you can see that the horizontal pair of lines is the view from Earth. So if you have any particular moon that is moving in that circular orbit around Jupiter, you can see that in the diagram that's showing right there, if it starts at the bottom of the circle and it's moving counterclockwise, the first thing you're going to see is view from the Earth is you're going to see a transit ingress. So you're going to see it in front of the actual planet. And then a little bit later on, you're going to see that it's going to have a transit egress. So it's going to move off the disk of Jupiter. And then you're going to see that the light coming from the sun is coming from a different angle, and therefore you could then see the moon casting a shadow on Jupiter, and that one's labeled SHI for shadow ingress, and then the shadow will egress. And at first glance, if you look at that diagram, you sort of assume that you're always going to see things in that pattern. Transit in, transit out, shadow in, shadow out. And then when you get around to the other side, the left-hand side of the diagram, the occultation disappearance is where the moon's going to disappear from Earth's point of view because it's behind Jupiter. It's then going to reappear from behind Jupiter and then go into Jupiter's shadow and then come out again. As I said, that's idealized. If the Earth is near opposition, those two lines coming from the Earth and the two lines coming from the sun are almost exactly coincident with each other. So you can actually have something come in as a transit and then have the shadow come in before the transit ends. So you can actually skip over some of those events. So if you go through the listing wondering, how can you have an occultation disappearance without an occultation reappearance? It's because it reappears inside the shadow, and what you see instead is an eclipse reappearance. So there's a couple of things that I've had people send me questions over the years when I was there saying, I don't understand why you're missing some of the events. And it's because people look at that diagram and assume that that diagram is correct all the time. If you go to the actual listings, there are some events in there that are designated with either boldface or italic. That's a perfect place to stop. If you look on the right-hand column, the far right under the date for the 24th, that boldface one indicates, and if you look at the line, it says shadow ingress. If you look at the line above it, that also says shadow ingress. So you have, in this case, moon number 3, which is Ganymede. Its shadow goes onto Jupiter, and then a short while later, Io, which is the closest moon, its shadow goes on. So the boldface indicates there's actually 2 shadows on the planet at the same time, and those are relatively rare. There's also a few occurrences in there where the date is in italics. They're a little bit harder to spot, which is rather fitting because, yeah, there's one right there. The reason it's fitting is because that indicates that 2 transits are happening at the same time, and transits are much harder to spot than shadows because unlike a black blob moving across the face of Jupiter, you're looking for the actual image of the moon itself, and that requires a bigger telescope and some pretty high quality optics in order to actually see it. And the one thing that is kind of interesting is that from year to year, if we just scroll back up to the start of the first page again, right there at the very bottom, I actually calculate that every year, the total number of events. And it's amazing that it's always within about 100 of the same number year after year after year. I often thought when I first took over as handbook editor, when I actually had to produce these things it was part of the job. Now I do because I just like doing it. But I was always worried after the first year that, well, what happens next year when I'm going to have to take a page out or have so much stuff I'm going to have to add another page, and it just doesn't happen. There's just enough of those events as you sort of see it. The other thing that's worth noting is that in the Sky month by month, and most other publications like Sky News, Sky and Telescope, they usually have a little diagram that sort of shows a little sine wave showing the Jupiter in the middle, so you can simply look in your telescope and see which moons are which. And in the case of Jupiter, that's pretty straightforward because from our point of view, we always see Jupiter actually edge on. So if we scroll back up to,
Scrolling back.
It's going to be around page 119, I guess, in the current edition.
Okay, here we go.
So let's back up a little bit.
There we are, yeah. So that's these diagrams.
Yeah, that's those diagrams. And in the case of Jupiter, it's pretty straightforward because they move from one side of Jupiter to the other side of Jupiter because we're effectively seeing the Jupiter system edge on. So there's no really extra complication to it. If we go back down to the one for Saturn, which is going to be on page, and I don't provide this one. This data is provided by Larry Bogan, who's from Nova Scotia. I've known him for quite a long time. He provides the ones for the same things, but for Saturn. And the reason why Saturn is more complicated is because as Saturn moves around the sun, we see its rings and we see the orbits of its moons from different perspectives. So you'll notice that the two main things that are different is because you're actually seeing the orbits not edge on, when you're trying to figure out where you should look for the moons, you have to check to see which side of the sort of the slope of the line. So for example, in the little illustration diagram he's got right there, we're showing the date with little dashed lines for date on the 1st or just after the 1st. Normally, in the case of Jupiter, you could simply just take a line and draw it up and it's not that big of a problem. But in the case of Titan, if you just zoom in there a little bit on the April diagram, you can see that as Titan goes around, you have to figure out, are you seeing Titan when it's at the top of that dashed line or where the dashed line is just to the right? Yeah, right there. You don't know, and you have to figure that out from the curve of the diagram. So that part is a little bit strange compared to the Jupiter diagrams. And the other part that's really interesting about the Saturn diagrams is you'll notice that there's a little arrow on each of the diagrams that shows you that the moons are moving counterclockwise. And at first glance, you might think, well, that's kind of interesting. But every now and then, and I had to deal with this one year, as we go through the actual plane of Saturn's rings as viewed from Earth, that arrow changes. And I made a little, I don't know if you can see this here, I made a little diagram sort of shows this. So this is showing, for example, Saturn's rings moving in one direction. And on the other side, they're moving in the same direction. You can just take this yourself, just take a piece of paper, draw an arrow. In this case, I used a marker. I can see through the marker through the page. So I turned it over and made an exact image of it on the other side. So if you're looking, for example, at Saturn's moons, and Saturn's moons are as they are now in the handbook for this year, they're moving counterclockwise. As you look at the rings more and more edge on, you'll notice that what happens is after you go through the ring plane, they're now moving clockwise. And everything changes.
Oh, man.
And there are some editions of the handbook where this will actually happen halfway through the year because we're actually passing through the ring plane. And if you don't realize that the arrows have changed, you'll run into a real problem trying to figure out exactly what moons you're looking for.
Oh,
In this
doesn't happen this year. Darn.
The rings are really, really already open, so it's not a problem. But if you go back and look at some of the past years, if you have a collection of handbooks going back 20 years or so, and just take a look at that Saturn section, you can watch the rings closer and closer to edge on, and then the arrows flip once we pass through it.
That's so cool. How often does that happen, Pat?
Well, Saturn takes 30 years to go around the sun.
Here's an image from 2010.
Well, hold on.
Yeah,
let me
so
on the spotlight.
it would have an equinox in between those, so about every 15 years.
Okay,
roughly.
cool. James, I'm going to stop sharing so we can see that figure. Can you show that again?
You can see the, it's kind of blurry.
Oh, yeah, it's like flat on there.
Almost flat,
Wow.
but not quite. So that was 2010. Let's see what
Huh.
2011 brings us.
And then
Must have been the year before.
Pat, we have a question about, do you have the year before on you, James?
Here we go.
Oh, perfect.
Here's 29.
Up a little bit.
Whoop. You can see the arrow changes direction there.
Huh.
It's going from left to right in July, and by November, it's going right to left.
That's so cool.
Oh, to answer the question about
blurry.
the fine horizontal dots on the April 1st row, that's basically an example that Larry put in to show how to actually read it. So what he's done is he's shown it for April the 1st at 4 o'clock Eastern time. So 4 o'clock Eastern time is going to be about 8 o'clock Universal time. I think in April, now we're on daylight time then. I can never keep track of when we're on daylight time and when we're not on time. So
Yeah,
typically
yeah.
what you're seeing there is he's drawn the line for the particular time at which he wants to do the observation. You find where they intersect the actual sinusoidal lines that indicate the actual moons, and then you draw the dashed lines up. And if you look, for example, in the case of Dione, you can see that the Dione is starting to move towards the left. It's already gone as far to the right as possible. So if the curve is moving towards the left, that means that you want to have the dot, it's going to be below Saturn. And if you look at Titan, Titan has not quite reached that distance, so that's why it's over there on the upper right.
Right. So, okay. So it's, so first of all the planets are orbiting counterclockwise from our point of view right now, right? And so Titan has already passed this point, which would have been extending this curve backwards. So let's take another example. So if Titan were here instead of here, we'd be looking at this point on the curve where it's increasing off to the right.
Yeah.
And then while it's on its way away from us, we're looking at when it's coming down on the backside.
Yeah. And then as Larry notes, if you're using a telescope with an odd number, the image is going to be mirror flipped.
Oh my goodness.
So there's that usual problem. That's if you were looking through binoculars, that's what you would see. But depending on the type of telescope you're using, it may be upside down or flipped left to right as well. So it's,
wow.
Again, that's why it's sort of complicated.
Wow. Oh man. I don't know. Like, wow. There's so much visualizing of images and like spatial awareness involved in this.
Well, see, the other thing about Jupiter is that Jupiter's 4 moons are all so bright, it's pretty hard to mistake them for a star. Whereas the moons of Saturn are quite a bit fainter. And if Saturn happens to be in an area where there's a lot of faint stars, you're trying to figure out which faint star you're looking at that's a moon compared to the other one. So that's part of the reason why it's a little bit tricky as well.
Wow. Oh boy. Out of curiosity, did I just miss January, February, and March for satellites of Jupiter or Saturn?
It's too close to the sun to view.
Oh, duh. Okay. I was wondering. I was like, why? I mean, seems like a big oversight.
Yeah. And that's also why the January to March is missing for Saturn. It's around the time when it's too close to the sun to actually see anything.
I see. Okay.
Both of those planets are in the same part of the sky right now. In fact, we're coming up to what you'll see in the sky month by month is italics and bold item in December, where Saturn and Jupiter are within a half a degree of each other, which is a very rare event.
That's exciting. That's going to be December 21st or so, 20th?
I believe that's it, yeah.
Yeah, it's close to Christmas.
And the particularly exciting part about that is they're within like 6 arc minutes or something like that, right? And it's like the first time this has happened. The Observer's Handbook says so since 1623.
December 21st.
December 21st. Okay. So definitely something to go and take a look at. This is, since we have a shorter section this time, because we're covering dwarf planets, comets, dust, all that stuff next time, we actually have quite a bit of time for questions about the planets this time. So if you guys have any questions regarding any of the planets, Pat, did you want to cover anything? Please, sorry, first, let me finish that thought. If you have questions, please type them in the question and answer box. And then Pat, do you have anything else that you would like to chat about before we get into questions?
No, I think the main thing for most of the thing is covered if you actually read the section for each planet. And fortunately, not all the planets are up at any one given time. So especially Mercury, it's sort of, it's there and then it's gone. So when Mercury's in, you can read the section on Mercury, and when it's gone, you can concentrate on some of the other planets.
That's true. And you can keep an eye on the sky month by month section to see what planets are going to be up at the right times. And it looks like, I guess these lines are indicative of the rings of Saturn. Is that what these interior ones are? Yes, they show you the actual extent of the ring system. Okay.
The one moon that isn't actually drawn in there is Iapetus, and that's because it's got a fairly highly elliptical orbit. So there's a little section at the end of the text introduction for it that talks about Iapetus. It's also about the same brightness as some of the fainter moons. Yeah, that little table. Yeah. Because it's so far away from Saturn, and it's also very its orbit is tipped quite a bit compared to the other ones. It's easiest to find it when it's either exactly north of Saturn or exactly south of Saturn. So that's what the times are there. So it's either when it's exactly above Saturn, exactly below it, or as far to the one side as possible.
Right. Okay.
And I think Larry notes that it's about 2.9 times the size of Titan's orbit. So if you go back to the diagram, you can see that Titan's orbit is the largest circle around, or circle there. The one for Iapetus is 3 times that size. So you can see why the diagram.
Yeah, that would be silly. Yeah.
You need 3 times as many pages to cover that section of the head. That would as well.
That's a very good point. So on page 231, I know this isn't the Saturn's satellites, but this is, hold on, 231, Jupiter's satellites. How do you find 2 or 3 simultaneous transits? I think we talked about this briefly, had to do with the bold.
Yes, if you just scan down through the table looking for items that are in boldface, that'll tell you when there's 2, either boldface or italics. That'll tell you when there's either 2 shadows or 2 transits. There is the odd time because of the geometry where you can actually see 2 transits and 2 shadows at the same time, but that's quite rare.
Wow.
And a few years ago, there was actually a case of a triple shadow transit. But I believe the next one of those doesn't happen until the year 2030 something. So I'm not really too worried about it at the time.
But you're not
upcoming
already
in
there?
June. In June, we have 3 double shadow transits.
Oh, wow.
So there's one on the 4th, one on the 11th, one on the 18th.
Oh, man.
Yeah, the problem is that generally half of those events you won't be able to see because, for example, if you look at the one on June the 11th, that's 1400 Universal Time, so that's going to be around noon time for noon or early late morning for most of Canada. So Jupiter's going to be up during the daytime.
Okay.
So if you do a lot of observing for Jupiter, what you tend to do is you sort of just mentally know that, for example, in Halifax, I basically have to add 4 hours to the time here. So if I want to observe at 10 o'clock, I add 4. That takes about 2 o'clock in the morning. So when I go looking for things, I'm starting on each date at around 200 hours. And that's about when my evening is going to be.
So for example, if you were looking at June 6th at 200 hours for transit, you would be going out June 5th at 10 p.m.
Yeah, well, 11 because it's daylight silly time.
Oh, right, daylight.
But that's what you're looking for, because you sort of think, well, you're going to look for things around your own time, like 8 o'clock at night. But 8 o'clock at night and 8 o'clock Universal Time don't always line up with dark skies.
Yeah. Okay. There's a question. Hold on, let me grab some more questions from the Q&A. Oops. Can you see retrograde in the guide? Could you explain how that happens? This one I've never really understood. I guess retrograde motion is when it appears to be going in the other direction, even though that's just because of the relative motion of us, which I think only happens with.
If I can answer that, retrograde
yeah, sure.
was a puzzle for the early astronomers, like 1,000 years ago. They couldn't figure out how this could possibly be. So they came up with all these weird and wonderful planet maps, or if you like, or models, where there was little epicircles or epicycles, where Venus would go forward and backwards and all this kind of stuff. And what happens is the Earth is moving as well as everything else. So we're moving faster than the outer planets, and the inner planets are moving faster than we are. So for example, if you're looking at Mars from Earth, we're moving toward it right now, relatively in the sky. Mars is getting larger and larger. So that means that Mars appears to be moving westward, but it's us moving eastward that's causing that. And the same goes for all the other outer planets. For a while, as we get close to opposition, for an example, Jupiter is straight opposite us from the sun, and it has been moving from west to east, which is what it's supposed to do. But then all of a sudden we overtake it and we go past it. Now it's moving from east to west. It's retrograding.
Huh.
So the planet's not moving backwards, it's us moving faster. That's what causes retrograde motion. So you'll see a planet will come to a standstill and then start moving backwards. And then eventually it'll stop, and then it'll start moving in prograde motion, or west to east.
And when you say backwards, you mean like this is
East to
we're
west.
talking east to west over a long period of time of like you would maybe notice it if you're looking at the background stars, but it's not like
That's exactly how you would know it. Yeah.
okay, it's not like the moon's going, hold on. No, if I'm north and you're south, west is over there. So the moon's not going like this and Jupiter's going like that. It's just that they're not going in opposite directions in a single night. They're all seeming to go in the same direction in a single night. It's just that Jupiter's seems to be moving in the opposite direction compared to background stars.
Well, the moons are moving with it. Yes, you're
Yeah,
right.
sorry, I was talking about the
Against
moon,
the
the moon,
background
moon.
star.
Yeah.
I can answer the question about the when's the next quadruple shadow transit.
Okay.
It's impossible to have a quadruple shadow transit.
Really? Why is that?
I gave a talk for the Dark Sky Weekend at Kedge last year called The Visible Moons of Jupiter. And it turns out that the 4 moons are in an orbital resonance. So it's impossible for them all to line up the same way. So you can have 3 of them doing that. So you can have 3 shadows at the same time, but every time you line up all 3 of them, the 4th one is nowhere near to be, it's always way off on one side or the other.
Right. I guess that, because I know that happens in systems where the TRAPPIST-1 system, where all the planets are really, really close together. And it happens because if it weren't in resonance, the planets would all, well, in that case, the planets, or in this case, maybe the moons would all smash into each other.
And if you look at our system, Venus and Earth are in a resonance, which is why the transits come the way they do.
Right.
I think it's an 8-year cycle, but of course the line of nodes has to be lined up with the sun, and that only happens very rarely.
Right.
But that's why if you take a look at what's happening with Venus right now, we have a really brilliant Venus in the evening sky this time of year. It's going to happen again in 8 years' time, and again in 8 years' time after that, because the Earth and the Venus come back to the same relative positions to each other.
Right. And this we saw briefly. Anyone who was joining us in Insider's Guide to the Galaxy, we were looking at Venus and how it lined up with the Pleiades a couple weeks ago. And it was cool. It lines up in the exact same spot every 8 years, like nearly to the day.
Yep.
Yeah, and in 8 years,
Interestingly,
it's even better view because it's going to pass even closer to the center of the cluster than it did this time round.
Yeah.
Ooh.
When it was completely overcast in the Maritimes and nobody here saw it. So,
oh man.
so I'm glad that hopefully the one in 8 years' time will actually have clear weather and it'll actually be a more impressive show.
I hope so for you guys.
I was going to say that interestingly, Jupiter is what causes that resonance between Earth and Venus.
Oh, really?
Jupiter's influence, gravitational influence, is huge. And
Wow.
that's what causes that 8-year resonance. 8 years for Earth to go around and 13 years for Venus to go around. No, pardon me. When the Earth goes around 8 times, Venus goes around 13 times. That's what it is.
I see.
There
Okay.
are other resonances too. You find them in the asteroid belt, and it's caused by Jupiter's influence. And you find it in Saturn's moons, Saturn's rings. There are gaps in the rings, and that's because of the resonances caused by the planet's gravity.
Wow. Wow. It's a tricky thing to get your head around, all of that sort of stuff. Geez, maybe my brain's just not working today.
There's lots to learn. Yeah.
Oh yeah.
Somebody asked about the retrograde in the guide. You'll
Yes.
find it in the Sky Month by Month text on the left-hand pages. Bruce McCurdy's text in there tells you when the planet's in retrograde motion and when it's not. When it's going prograde. I'll just see if I can find one. I'm pretty sure.
Let's go look at the sky for me.
Yeah, Jupiter is, it mentions Jupiter is in prograde motion.
Oh yeah, and here it says
in the April month by month.
And then in May it says it slows to its first stationary point on the 14th, after which it will spend the next 4 months in retrograde motion.
Exactly.
Cool.
And the same goes for Saturn, because it'll be retrograding as well.
There's a question from Lori Roche, which is, does Mercury also have a specific cycle like that orbital resonance that goes along with Venus and Earth? Is that how all the planets work?
Mercury is more influenced by the sun, and it's pretty sure it's tidally locked. Can you confirm that, Pat? Pat's not listening. He's
Pat
typing away.
is typing violently. Pat
Yeah, I think it's Venus and the Sun together have an influence on Mercury. It's not quite in. It's in a 3-2 resonance.
Right.
So it rotates. It either rotates for every 3 times it goes around.
oh yeah, so that day is longer than its year.
Yeah. So if you actually had an Earth-centered or a Mercury-centered model of the solar system with Mercury at the center, what you would see is the sun would go around it. It would stop and do retrograde. And there'd be 3 places about 120 degrees apart where the sun would actually stop, back up, and stop, and then go forward again. And those 3 spots would get a lot of extra heat. And that's why the calorous basin, the heat, calorous comes from the Latin word to heat. That's how the calorous basin got its name, because one of those 3 places occurs right over the calorous basin.
Interesting.
If you want a really good suntan, that would be a place to go.
Yeah, right. Where the temperature is 610 degrees Celsius.
A little toasty there. Bring
Yeah,
your
you want
sunscreen.
SPF 10,000 at least.
Yeah.
Yeah.
Oh wow, that's wild. Okay, this is something I find really interesting. There's a couple. I'm sure there's some neat tools out there. Do you guys happen to know any tools off the top of your head for helping to visualize the movement of the planets and the orbits of the planets? The one for me that jumps to mind is Solar System Scope. But if you guys know any off the top of your heads, in case anybody's curious. So I'll send out Solar System Scope. It's like a nice little model for visualizing the orbits of the planets. I'll see if I can share it.
Well, there are a lot of the planetarium software will let you do that. You can sort of sit above the solar system and lock on a particular planet so that it doesn't move relative to the sun, and then just watch all the other planets go around relative to it. Because usually the biggest people I think a lot of people have a trouble with is dealing with a reference frame that's not the Earth. Yeah,
because the Earth is so commonly our only perspective on things, right?
Yeah, so if you go to Venus, you can watch the Earth do retrograde loops because its orbit is inside the orbit of the Earth. And if you're on Mercury, you can watch all the other planets do retrograde loops. That's
really cool. That's okay. So I would guess something like Stellarium or something like that would be good for that, eh?
Yeah, Stellarium. The one I tend to use is Voyager. It's an oldie but goodie.
Okay.
I think most people typically tend to sort of stick with whichever one they're most familiar with. And some of them are designed specifically for first-year astronomy students. So, for example, there's a student version of Voyager, and I think they've changed the name since then. I got it with one of the textbooks that I use, and it's designed specific to do things like showing the phases of the moon. It's got special little modules. You just pick it from the learning menu, and it's got preset things that show you concepts that otherwise you could figure out how to get the software to do it, but you'd have to know you need to lock this on and set your viewpoint to here and then run it. They've got all that set up. So you say, I want to see how this concept works. So you pick it, and then it just sort of shows it to you.
Cool. Okay, wow. Well, that's fantastic. I think we have gotten through all of the questions that we have. So if anyone's got some last minute questions, we'll throw them out there. Pat, otherwise, I really appreciate the time that you've taken to explain all this stuff and add in that comment about Voyager as well and the planetarium software. I do recommend for folks to go and try to visualize this stuff. So that's one of those things that having computer programs is really helpful for, or lots of free time, which many of us have right now. So spend some time thinking about how the solar system works and how things would look from different places, and feel free to set up models in your home. And I recommend using single bulbs to imitate the sun, and it's all sorts of cool stuff you can do. James as well, thank you so much for being here. And next session is dwarf planets and their satellites, comets, dust, meteors, that sort of stuff.
All kinds of stuff, yes.
We're going to cover lots there, and so we'll see you guys all next time. One last reminder that the last session, which is scheduled for June 1st, is going to be combined with the May 25th session. Thanks, everybody. Thanks, James and Pat.
You're welcome.
Nice to be here.
We will see, James, we'll see you next week. Pat, we'll see you again soon.
Okay.
Bye, guys. Take care.
Bye.